So we've talked about there are three types of problems. So far we've seen problems where it is less than or below the z-value, probability that it's greater than the z-value, and now let's look at problems that are between. So again, remember that we've looked at values that are below. These are the two problems in the previous videos where we talked about the area below a z-value. That's actually what our table reads to us. We've looked at problems where we're looking for the probability above a z-value or greater than or equal to, so the right area, and we talked about doing 1 minus the answer we get from the table because the table reads the left-hand area. And so now let's look at examples where we want between. So the first example I want to look at is the probability that z is between 1.35 standard deviations below the mean, the negative tells me it's below, and 2.04 standard deviations above the mean. And here's my picture. My mean, of course, would be 0 because that means I'm 0 standard deviations above or below. And there's the negative 1.35, the 2.04, and it's this area in between. Now, if I go back and think back to the previous work, I know if I look up 2.04 on my table, it will give me this area. So I'm not going to show you doing that because it's more cumbersome to put the book underneath here and the camera, but you can look that up. And if you look that up, this area is 0.9793. So the probability that we are below 2.04 standard deviations above the mean is 97.93%. However, when you look at the original problem, that's a lot more than I want. There's a piece here that I don't want, which is this piece. So if I were color coding, this piece here I don't want, which is this piece. You can see it in this picture. So when I look up negative 1.35, I find this area, and this area is 0.0885, and that's the area that I don't want in this picture. So I need to take that away from this answer. So it makes sense to get the answer to my problem, I need to take 0.9793 and subtract off 0.0885. And that difference in area would be my answer, which is decimal 8908, or 89.08%. That's the probability that we get a z-score between negative 1.35 and 2.04. All right, let's try that again. So here I have two z-scores that are below the mean, and I still am interested in knowing what's the probability that I fall between negative 2.36 and negative 0.39, this area that I've shaded already. Well, I know that if I look up negative 0.39 in the text, I get this area, the area below, which looks a lot like my picture, except for that it's got an extra piece here that I don't really want. But it's a start. So it's going to have more than I want. So let's look that up in the book. I'll give you a second to try. You could try following along, or you could pause the video a second to look it up. If I go on the negative side of my chart, I look for negative 0.3. I go over to the 9 column for the second decimal, And I see that that area for this here is 0.3483. But again, that's more than I want because I don't want this little tail. That little tail is this area. So again, if I'm color coding, the part that I don't want is this tail here, which is the answer I get when I look up negative 2.36. When I look up negative 2.36 in my chart, I get this area. So let's look that up. Again, negative side, look up negative 2.3 over to the 6th column, and I see that that area is 0.0091. It's a really small area, but again, it's still an area that I want to take off. And so this needs to come off, needs to be subtracted off from that. So the answer to this problem would be 0.3483 take away 0.0091. And so doing that subtraction in my calculator, I get 0.3392 as the final answer. So the probability that Z falls between negative 2.36 standard deviations below the mean and 0.39 standard deviations below the mean is 0.3392. Certainly you can write this answer as 33.92% if you want, but there's nothing wrong with the answer 0.3392. The last question that we'll look at, the last example, is let's check the empirical rule. We know at least part of the empirical rule. I won't do the whole empirical rule. But we know the first part of the empirical rule says that if we look one standard deviation to either side, we should have about 68%. And it's an approximation. So that means Z is negative 1 to 1. So the probability that Z is between negative 1 and 1, we should have about 68%. Well, let's check it. Here we go. We know if we look up this area, we look up 1 in our chart, we would get this area, which of course is more than I want. So let's look that up. So look up 1.0. So actually what we're looking up is 1.00 in our chart. Okay? So that's going to be in the 1.00. It's going to be in the very first column of the 1.0 row. So let's look that up. So on the positive side, looking that up, and I get 0.8413. Well, that seems to make sense. If you look at it, this is 50% to here. Yeah, okay. That's a lot more than I'm expecting this answer. However, I know that this has a chunk of this. If I go back and I put in the 1 here, there's a chunk here I don't want. That's this chunk here, right? Which happens to be this area here, the area below negative 1. So again, let's look up negative 1.00 and let's look up that area. So let's go to the negative side, flip to the negative side of our chart, doing the same thing. And this time we find the area to be 0.1587. So that's almost 16% that has to come off of this. Oh, that's going to lower that number quite a bit. So we're talking about 0.8413 minus 0.1587. And when I subtract those, I get 0.6826. Well, that's pretty close to 68%. That is about 68%. So that makes sense. Our empirical rule, or our 68, 95, 99.7 rule, this part checks out. I don't know about the rest. We didn't check it. but check the first part checked out. And that's how we do areas between. So now you know how to do all three types. If you've watched all the videos, we know how to do basically anything that's thrown at us. We have below a number, above a number, and between numbers. And of course, between numbers really use the first type, and then we subtract. Hope that helps.